So time is another example of a scalar quantity. Okay. Likewise, the length of a table. How about the length of a table? Well, a table is like 4 feet long. And it doesn't matter whether the table is oriented north, south, east, west, up and down. We measure the length of the table, and it's 4 feet long. Direction is meaningless. So length would be another example of a scalar. Okay. Now, how about force? Most of you know that force is a push or a pull. Is force a vector quantity or a scalar quantity? In other words, does it matter what direction we're pushing or pulling? And when I say it that way, it probably becomes clear that yes, force is a vector quantity. Because if I'm pushing against my hand, I'm pushing it that direction. Let's see. I don't have 3 hands, unfortunately. Okay. Let's do this. This is a demo I do with a water bottle on a table, but we'll see what we can do. Okay, if I push this calculator with 1 finger, all right, it's going to tip over this direction. If I push on the calculator with 2 fingers, it doesn't go anywhere, right? Because this finger is being balanced by the push from this finger. The forces are in opposite directions, so the calculator doesn't go anywhere. But if I push with 2 fingers in the same direction, I'm going to send the calculator flying. So if the directions of the 2 forces are the same, we have a different outcome than if the direction of the forces are opposite from each other. So force is definitely a vector quantity. Okay, let's see what else we got here. We have other examples on this list here. Okay, acceleration, it turns out, is a vector quantity. When we change our speed, change our velocity, the direction matters. Other scalar quantities are temperature. It's 70 degrees Fahrenheit, and it's meaningless to say 70 degrees Fahrenheit to the north. It's just direction is meaningless. So that's a scalar quantity. Let's see, time. Yeah, voltage, like the voltage of a battery that you get. We buy a 9-volt battery. We can hang a number on something about the electricity in that battery, 9 volts. But it has no meaning in terms of 9 volts to the north or 9 volts left or 9 volts upward. That doesn't have any meaning. So voltage is a scalar quantity. Okay, vectors versus scalars. What do you need to know? You need to be able to distinguish between the 2 of them, and you've got to be able to give us examples of both of them at this point. The reason we care about vectors versus scalars is because there's certain things that you can do with vectors that you can't do with scalars. And it's important to be aware of what we're talking about, vector quantities or scalar quantities, because it affects how we can solve problems and even the kinds of problems that we can solve. If there's vectors, we can do a lot more with them than scalars. Okay, let's see. Let's move on here. We're almost to the end. We're going to talk about instantaneous versus average speed. So this concept of instantaneous quantities versus average quantities. Okay, so let's look again at a quick example here. Say my home is 10 kilometers away, and I would like to go there soon because it's getting kind of late. I need to get this recording done for you guys for tomorrow. Anyway, my home is 10 kilometers away, and I can drive there in 15 minutes. And the question is, what is my average speed in meters per second? Or what is my speed in meters per second as I drive home? And I will show you the clipboard here to do it. Okay, so we've got some blank space here, so we'll just go with this. Okay, so it's 10 kilometers in 15 minutes. That's what I'm given. What do I want to find? By the way, if you would, please pause the video at this point and try to solve this yourself, okay? And then when you get an answer or get stuck, then start it up and watch again. So moving on, we are trying to find our speed, and that's good. And we want to find it in meters per second, because meters per second is kind of our standard thing here. And if you solved a problem and you did it in terms of kilometers per minute or kilometers per hour or something, pause it again and see if you can convert your answer to meters per second. Okay? Now, our equation that we're going to use is V is equal to distance divided by time. And we have 10 kilometers divided by 15 minutes. okay? Now, we don't want to keep this in kilometers and minutes. We want to convert it to meters and seconds. So we're going to throw in some conversion factors here, which you can do in separate steps if that's easier for you, or you can do it in one thing like I'm going to show you, but it comes out the same way. So if we want to convert kilometers into meters, there are 1,000 meters in a kilometer. Okay, 1,000 meters per kilometer. Remember, the prefix kilo means 1,000. So kilometer literally means 1,000 meters. And that conversion is something that you should remember, should memorize. Okay, so that will get us, now the kilometers will cancel, and that means that the numbers we get will be in terms of meters, which is what we want. Now we also have to turn the minutes into seconds. So we are going to say that there are 60 seconds per minute, or you can say 1 minute is 60 seconds, 1 minute per 60 seconds. And we want to pay attention to the units again, like I've been saying, to make sure we have it set up right. Now, when I set it up like this, the minutes in the numerator cancel out the minutes in the denominator. And I'm left with seconds in the denominator and meters in the numerator. So our answer is going to come out to be meters per second. And that's what we want. And by paying attention to the units, we can see that we're doing it right. Anyway, now we have it all set up, so we can do equal sign here, get out our calculator, and we're going to say 10 divided by 15 times 1,000 divided by 60, and we wind up with 11 meters per second. Okay, that's our answer. It comes out to be about 11 meters per second. Now, this turns out to be about 25 miles per hour. I'm just kind of saying that here for us so we can compare and we can continue on with this discussion. So with the given information here, we find out that my average speed is about 25 miles per hour, or about 11 meters per second. Okay? Now, that's assuming that I leave the school, I drive 10 kilometers, and I get home in 15 minutes. My average speed is 11 meters per second. But in reality, do I actually drive that 11 meters per second or 25 miles per hour? Am I driving 25 miles per hour every second, every foot of the way, all the way home? Probably not. Chances are I'm going to have to stop for a stop sign, or I'm going to have to wait for a traffic signal, or I'm going to have to wait pulling out of the parking lot for a couple trucks to go by. All right. So sometimes I'm going faster than 25 miles per hour, and sometimes I'm going slower. Right? So we've just figured out that my speed going home is 25 miles per hour. Now, could I actually get pulled over for speeding on the way home, even though my average speed is 25 miles per hour all the way home? And I think you probably see it. Yeah, I absolutely could. Like, suppose that I did have to wait for a convoy of trucks to go by before I pulled out of the parking lot. And then I got stuck at every traffic signal on the way. Excuse me. I got stuck at every traffic signal on the way home. And so I'm driving 50 miles per hour through my neighborhood so I can get home in time to watch Jeopardy or whatever. Okay. Police officer is going to pull me over because I was driving 50 miles per hour. And it wouldn't do me much good to say, but officer, I left school 15 minutes ago. It's 10 kilometers per way. Clearly, I've been only driving 25 miles per hour. Well, that's my average speed, but my instantaneous speed, my speed at that moment, when the police officer saw me, at that moment, my instantaneous speed was 50 miles per hour. And that's really, really dangerous. And it happens to be illegal, so I get a ticket. Okay? So instantaneous speed is the speed at any given moment. The average speed is the speed over a long period of time. And there may be variations from moment to moment within that period of time. It's just an average speed when we smooth out all the bumps and get an average number. Okay, that's enough for one day. What did we cover today? We looked at, let's see, here it is. We got this idea that all motion is relative, which is fundamental to physics. We compared the difference, distinguished between speed versus velocity. and we use that to lead into the, the concept of vectors versus scalars. And finally, we looked at the difference between instantaneous speed and average speed. And that's the same concept goes for any value. Instantaneous values versus average values can vary just the same way as these. Now, along the way, I introduced how I want you to solve problems, which is the GFEW format, and that is in the classroom now, so you can see that. And also with this speed versus velocity, I mentioned at the start of this class that vocabulary is very important in physics, that you have to know the words and what they mean to even be able to. I mentioned at the start of this course that vocabulary is very important to even be able to understand questions, or be able to understand what you're being asked, or be able to understand the conversation. You have to know what the words mean. Now, speed and velocity are words that you've heard before, but in physics, they have specific meanings, and it is very important that you know the physics meaning of these words. And speed and velocity are prime examples of that. In your English class, these are probably synonyms. They mean exactly the same thing. In physics, they mean very different things, and it's important to know and be aware of the difference. Okay, thanks for your time, and we will see you next time.